This is Robert Kraft, and I'm coming to you live on SNNLive, and we're at the MicroCap Conference 2017 in New York City. With me right now is John Rice from Sigma Labs, publicly traded company with the symbol SGLB on the NASDAQ. John, welcome to SNNLive.
Thank you. It's nice to be here.
It's great to have you on. So, to start for our audience, let's get an overview of the company.
Well, Sigma Labs is a 7-year-old company that manufactures special quality inspection equipment for 3D metal manufacturing. In order to know what you built in your 3D manufacturing machine, you need a product like ours to tell you in process whether it is in specification or not.
So before I get to the history, can you elaborate on that a little more? What does that mean?
Well, it means that to make parts with 3D metal manufacturing machines, that you need, what you're really doing is making sculpture with a laser and powdered metal. And there are a lot of variances that can occur in that process. It may be that some of the powdered metal clumps. It may be that it doesn't, that it sinters. And so we need to know, we need to have some way to know, wait a minute, is this part going to work? And what Sigma does is watch each part being made and determine in real time, is this part in specification? And if there is a flaw in the metal, we will see it and we will report it. Not all flaws mean the part is bad, but most do, and we detect them all.
So it's almost like a logistics solution for the 3D builders in a sense, right?
Yes, what it is an enabling technology. 3D manufacturing is today used mostly with metal for prototypes and design spec. In order to go into production mode, you need to have a quality system capable of inspecting in this technology in real time. It doesn't help to inspect after the mistake was made.
I was just going to ask, is it real time?
Real time.
So let's get a little history of the company. When did it begin and how did it develop to where it's currently at today?
Well, the company was started about 7 years ago by two scientists out of Los Alamos Labs. And their goal was to commercialize a number of technologies based on the fact that they were expert metallurgists. And they developed 3 technologies and were bringing them forward until about 3 years ago when they realized the work they were doing in in-process quality monitoring for 3D was so enormous as an opportunity, and the timing so right when 3D manufacturing machines for metal were now popular in the marketplace for prototyping, but the jump to hyperspace for this technology is you have to be able to make lots of parts on lots of machines because you can only make a few parts on each 3D manufacturing machine. So you need some unifying technology that will make the part made by every machine look the same, and that's Sigma.
So what would you say then are the company's competitive advantages when you consider all the competition in your space?
So far, we are not seeing any company that appears to threaten what we do. A lot of companies are looking at this problem, so I don't expect to be alone out here. The reality of the industry is it's so young. This problem was not understood to be serious until the last year or two. It was assumed that a 3D manufacturing machine would behave like a CNC machine, and a CNC machine with reductive manufacturing is very predictable. And you can do classic quality inspection by making 1,000 and cutting up 6, and you will know from those 6 that you have a statistically valid take on the production of that part. None of those rules apply to the current world of 3D metal manufacturing.
So what I really want to get at also with that question is the company's IP portfolio. Can you elaborate on that?
Yeah, that's a big deal to us. We went out to a major international firm, Kilpatrick Townsend, who has a lot of experience in this space. We interviewed several firms looking for people who had specific IP experience in our domain, and our domains are not necessarily described only as 3D. It's about metallurgy. It's about the importance of protecting algorithms and so on and so forth. So we've been very aggressive on that. It's a costly but necessary investment in a market like this. There are a number of different companies throughout the world to develop great 3D manufacturing equipment, and we want to be Intel inside. We want our label, our Sigma label, on each one of their machines. And having a strong portfolio in patent protection is essential to helping persuade them that's a good idea.
So another thing I want to talk about is the size of the addressable market that you're targeting. Can you also elaborate on that?
Sure. The metals market right now in 3D was said by Wohlers to have annual revenues of just shy of 100 million in 2015. And that was up 80% from the prior year. And their take is this is going to continue growing like that. Well, that's actually a very small market, and so far. And the reason is that this technology so far is being used as a prototype development technology while people figure out how and if to manufacture in quantity. GE has sort of led the market on this. They have committed themselves to 3D manufacture of 40,000 fuel nozzles. And that's a lot of nozzles when you consider that a lot in a machine might be 10 units. So the enabling technology, the thing that allows 3D manufacturing to become a standardized production manufacturing method is the use of in-process quality monitoring, which Sigma is doing. By having every machine inform and protect the quality, it becomes a production technology that will really work. The last point on this is that there's a holy grail for us, and that is we want our technology to close the loop to the machine. We want to work with the controls people so that if a part is going out of spec, we can send a signal to the machine saying you need to increase the power on that third part to the right and keep it in spec.
So what's your background? And also, can you elaborate a bit on the management team? Because I know some news has come out in that regard. So
Sure. My background is in doing turnarounds and turn-ups for companies. Very often as an interim CEO, to take a company from, say, level D to level M, and to develop a company towards a space where you bring in management teams in the future that are of the industry that you might not be able to attract in the early stage of a company. So in the case of Sigma, I've known the company for 3 or 4 years. I'm very fond of Mark Kola, who was the founder, a co-founder, the CEO, and who recently moved over to become CTO. And what we found was that Sigma, after the successful offering last February and the uplift to NASDAQ, there was too much to do and not enough people to do it. And part of the problem was, hey, wait a minute, we need to get our next version 3.0 of our software into the marketplace by November. And we need to service the possibility of mergers and acquisitions. Oh, and by the way, you have a whole bunch of new shareholders you'd never met before. And so we were trying to figure out how do we allocate ourselves. And because of my background, it was easy. I was an easy solution. That enables Mark to be CTO, which he is brilliant at, to capitalize on what we deem to be still our lead. As best we can tell, we are in front on this technology, and now we've doubled down. Now Mark gets to spend all of his time trying to keep ahead, and magically close the loop to the machine.
So what are some growth drivers then for the business?
Yeah, for us, their market has changed materially in like the last 6 months in terms of customer profiles that are coming in. What we have seen a year ago would have been installing at a major aerospace company, and they would put it in a lab with a bunch of prototype producing machines, and they do stuff with it. They weren't driven towards the market because they were just trying to figure out, will this in-process stuff work, and will we use it someday? Well, that's changing now. Now that you've got companies like Siemens, like Woodward, Pratt & Whitney, companies that actually have 3D metal machines doing things, making parts now, and they are looking for better solutions to increase the yield of those machines because of the problems that I've already cited. And so we're installing at places where if they have a successful experience with the work we do with them in test, the logical thing is they will then order it for, let's give me 10 because I have 10 machines or whatever they have. For us, that's the turning point. The tipping point of that launches a Sigma is a major company or two doing that. Suddenly the OEM people who can offer our product in theirs, so we can be Intel inside, suddenly those people will have pull marketing on them, where customers say, I see that this big company ordered a bunch, this must be good, okay, put it in. So that's our dream. That's what we're looking for next.
And where can our audience go and find more information about Sigma Labs?
They can go online and under Sigma Labs, and we are there.
That's sigmalabs.com. My name is Robert Kraft, and I'm coming to you live on SNNLive, and we're at the MicroCap Conference 2017 in New York City. With me again is John Rice from Sigma Labs, publicly traded company with the symbol SGLB on the NASDAQ. John, thank you so much.
Thank you.